Hello guys, welcome back to narsicloud.com. In our last video, we talked about DynamoDB and how to create a table and how to store the data in the DynamoDB. In today's video, we will talk about more details about how does the data get stored under the hood, and how do you search for the data, and what happens really to what are the things to consider when designing the database in DynamoDB, and the important factors about read capacity and write capacity units, and also read consistency. So these are the main concepts that you want to know when working with DynamoDB at the least. Okay, so today let's start with talking about how does the data get stored under the hood. Okay, so let's go to DynamoDB, and we have songs table created. In the songs table, we have a partition key name as a partition key and the sort key as a music director, right? Who composed that song. So let's go ahead and add the items to it. So the primary components of the table is basically the table and the items, and within the item you have attributes. Okay, so that is the first terminology you need to be familiar with. Now let's create the item. So let's say life is beautiful, and then music director RC. Okay, let's minimize that. So here since we gave name as a primary key, it will store the data using that primary key and sort key as well. So what happens really under the hood? So like I said, DynamoDB is a key value kind of NoSQL database, right? So if you look at the partitions, so basically whenever you store any data, it stores in the form of partitions. So it is a distributed database system, right? So in this case, I stored I gave name as a partition key and music director as a sort key, right? So what happens is it will have one function. Let's say this is called hash function, and what this hash function does is it takes a key and then generate the hash for that. So based on that hash, it will determine the bucket where does that data should go. Okay, so let's say this hash, so we saved life is beautiful, right? And sort key as a music director. So life is beautiful is the primary key, and it will compute the hash using that life is beautiful value. And let's say the hash that came out of this function is partition 1. So where should that go? So that will go here, this partition 1. So in the partition 1, what it does, life is beautiful. So like that, it will store the key and the value. This is the name, and then music director, because it is sorted by this is sorted by music director, it will sort the record. Let's say this is a Narsi music director, right? So here it will first, since it has only one row, it will store that row here. So let's say I'm gonna create another entry where, let's say I'll create another item. So the name of the song is life is beautiful. So let's say there is another song with the same tag name, and the music director is someone else, Vinay. Okay, so save that. So now according to that theory, it computes, because name is the primary key, right? It computes the hash of this value and sorted by music director. So go back to our board here. Again the same, because life is beautiful hash comes to the same bucket, right? and then it will store Vinay as a sort key because it comes after narc. So it will store here. So what happens is this sub it will store in the partitions. Now when you query by primary key, let's say go back here. So let's say I'm gonna query by partition key. So what I should do, I will give the value life is beautiful, right? What it does, it again computes the hash key of this, and it will determine the bucket. Oh, okay, so which bucket does this data belong to? So based on this value, it knows it has to go to partition 1. So likewise, it will have lot of buckets behind the scenes, depending on how much data that database has, right? So now it knows which partition it will go. But since life is beautiful, there are 2 rows. If you start searching by that, I will get both of the entries, but I would want only for let's say Vinay. Then you see this, it's coming in the sorting order, and then it will get only the Vinay ones. Okay, now if I go for search for narc, then you'll get narc. So that's why it is single digit millisecond latency. That's why it is so fast to determine where the data where the data is residing, and it knows exactly where to go, the location of it. So it's all about, when you say it is single digit millisecond latency, that means when you know where the information is, then it's all about fetching it, right? That's what is happening here. Now if I give some x value and it computes a partition hash value for that, and if it turns out to partition 2, then it directly comes to partition 2 and grab that data. All right, so that is how the data gets stored in the form of key, and this is the value. So basically this is the total item, right? So key is the name, and for this one, and value will be the life is beautiful, and that's why we call it as a key value type of NoSQL database. Okay. The next part is read consistency. So the concept is, when you create an entry, it stores into the partition, right? Likewise, we will maintain the copies of this data in multiple regions. So let's say if it's a multiple regions, then the same partition 1 kind of data will be there in another region, let's say region 2, and if you're maintaining region 3, then it will maintain the region 3. So whenever you copy the data, whenever you create an item, what it does behind the scenes, it will propagate those changes to all these regions. It could be the regions, or it could be, say, another availability zones within the same region. Okay, but the fact is, it is copying this data to multiple places, so that it maintains that high availability, and it makes it faster, right? I don't have to query just this particular partition 1 always. I can the other applications can always go to these other locations, right? But the read consistency, what it says is, there are 2 types of read consistency. Strongly consistent and eventually consistent. So strongly consistent read consistency is what it does. When we save the to partition 1, what we are saying is, okay, my mode, the mode of writing is, it should be strongly consistent. That means you don't return back until you make sure that this data is copied to these 2 regions. Then only you return this response back to me. That's what we are saying as a user. Okay, so what that means, so that we make sure, as soon as we get the response, successful write response, that means we are very sure that, okay, it's been copied to every other location. Then when I query for read, when we query for the same data, then I will get the latest up-to-date data. That's what strongly consistency means. If eventually consistency means eventually read consistency means I'm writing the data as a user. I'm writing the item into this table, and I said the mode is eventually consistent. What that means is this data will be eventually consistent with the other. It becomes eventually consistent. That means it eventually copies this data to other regions. So eventually consistent, there it at the most it would take a second or less than second. Okay, so let's say I return this item to this table, and immediately if I query, I might get the stale data. So that is the compromise you are going with. If you are sure that your application is okay to retrieve the stale data, and after 1 second or less than 1 second, if you query it again, you might get the latest data. So it all again depends on the use case, but just to let you know that there are two types of read consistency: strongly consistent and eventually consistent. Okay, and another important concept is capacity units. This is very important. DynamoDB table, if you look at our table here, our table, so capacity, you see which shows the provision free tier eligible, the provision ones, which is right now we are seeing read capacity units are 5 and write capacity units are 5. Okay, so what that means is whenever you want to read from DynamoDB, it requires some capacity units to be able to retrieve that amount of data. That is the concept. Okay, so so let's take read capacity units. So read capacity unit, let's say you have this one item, right? In this item, let's say this is 4 kilobytes of data. Let's assume that it's not 4 kilobytes, but let's assume that this is 4 kilobytes of data. And to be able to read this data, you need at least one read capacity unit. And again, that depends on if you want to read eventually consistent or strongly consistent. If you want to read one strongly consistent, if you want to read an item of 4 kilobytes of size and in strongly consistent mode, you need one read capacity unit. So if you were to write that one strongly consistent read of 4 kilobytes size, it requires one read capacity unit. Okay, or if you want to see two eventually consistent read of up to 4 kilobytes item, one read capacity unit. You get what I'm saying? So if you define one read capacity unit, that means it can read, that capacity is it can read item of 4 kilobyte size and only one strongly consistent read. It can read only one strongly consistent read. And the same one read capacity read capacity unit, it can read two eventually consistent reads, each item of up to 4 kilobytes. That means this capacity is 8 kilobytes and this capacity is 4 kilobytes. That's what read capacity unit concept. Then you can determine based on this calculation how much data you want to retrieve as per the use case in your application. That all varies. So right now, if you are unsure that how much data it's going to store how much data we're going to retrieve. If you're not sure about if it is not something that can be calculated in advance, then what you can do, you can put it in automated on-demand mode. So there is a concept called on-demand mode. So here you can put on-demand mode, and that will take care of it. As the application access patterns, based on that, DynamoDB automatically adjusts these read capacity and write capacity units. So write capacity unit is also the same concept. So it can read 1 KB. It can write 1 KB size of write with 1 write capacity units. It is straightforward. So if you want to write 4 kilobytes of writes, then you need 4 write capacity units. Okay, so just remember this basic concept, then it's all about calculating based on the use case. Okay, so that's what the concept about read capacity units and write capacity units. And coming to the items, so I think it's pretty much covered from the yesterday's video, and in this video we covered the important terminology about DynamoDB concepts, like the tables, items, and attributes. That's all about the data. So table, you can correspond that corresponds to regular table in the SQL database, if you want to compare SQL and NoSQL. The item corresponds to rows, and attributes in DynamoDB corresponds to columns in SQL database, SQL type of databases. And then you know what is read capacity unit and write capacity units, and you know what is read consistency, and which is of two types: strongly consistent and eventually consistent. Okay, these are the very basic concepts, and with these concepts you will be able to work in real time, and you will be able to explore the database DynamoDB tables by yourself. And there is another concept called indexes. How do we access based on access patterns? We define indexes. So I will cover that in our next video, and I'll go a little bit deeper on how to create index, and how does that work, and what is the use case that is being addressed by index. Okay, so with that we can wrap up the DynamoDB. And if you like this video, please click on like button, and please do subscribe, and we'll catch up in our next video. Okay, take care, bye.